Your RF PCB passed the simulation. Impedance looked correct. Insertion loss met the target. Everything seemed ready. But after fabrication, the measured performance changed. Insertion loss became higher. Return loss became worse. The frequency response shifted. The first thing to understand is simple. A simulation model is not the same as a manufactured PCB. Reason 1. Material variation. RF simulations often use nominal decay and DF values from a datasheet, but production laminate has tolerances. Even small decay changes can affect impedance, phase delay, and resonant frequency. At higher frequencies, this effect becomes more. Reason 3. Manufacturing tolerance. A 50-ohm transmission line depends on trace width, copper thickness, dielectric thickness, and stack-up control. RF PCB success is not only about good design, it is about designing with manufacturing reality in mind. RF PCBs demand micrometer level precision. Any process deviation spells trouble. Solder paste inconsistencies cause cold joints in matching networks. Even a tiny capacitor misalignment changes resonant frequency.